More of a hobbit,
Okay, so I'm going to talk about the robot here. This thing in the back here is our flag mechanism that flips the flag up. It also has a system where it goes back and forth, so we can bring it out and back because it goes through the 18 inches.
As you can tell, it's an autonomous program.
What just went up was our this block lifting system. It is a crowbar linking system, and you are not allowed to go there. And these hooks here are detachable hooks that we use to hang, and then this, which you don't see here, is our is a mechanism that keeps it from not falling. And here is in autonomous mode, we flick blocks using this, and we have an IR sensor over here, and we have a four motor drivetrain. I have 4 motors, and that's our robot.
Greetings, fair adventurers. We are RPG, the Robotics Programming Guild. Hearken our tale. We come from Tennessee, lands far away, centered around Mount Juliet to Nashville, though our members come from lands all across. A few of us have competed before in the Grand FTC tournaments, although many of our adventurers are newcomers to the game. A few competed before in FLL, and now we have come forth to take on a new challenge of the Block Party. As all great adventurers do when they first begin, we took to planning, drawing maps, and designing.
So the majority of our team this year, besides Joshua, Ryan, and moi, are people we've recruited. Either last year, on our old team, we mentored a couple of teams and showed them, FLL teams, and showed them our robot last year. And they, some of them joined, like I know Jeremy here, Mark, and I believe Jonah. And we picked up Miss Natalie at a fair while we were demonstrating our robot at our Wilson County local fair.
That sounds worse than it is. We picked her up.
We threw her in the back of the truck.
They're not going to do it. They're not going to do it.
Anyway, so we meet at a DCI hangar, actually. I believe
it's on the other side.
Sorry?
It's on the other side, I think.
Oh, no. Here is DCI Logistics. They fly out organs, medical organs to different hospitals, and we meet at their hangar. And so at the beginning of every meeting, we decide we discuss what we're going to do. So we generally make a list of things that need to be done in like a order of most important to least important, and we usually just discuss among one another. Then we decide, like I said, we decide what we need to do. And then we start our design, and I think Josh here is going to elaborate, but essentially we just script things out and make sure they're all ready for construction. Then we build, and we draw in an engineering notebook any prototypes we've come across or any failures. We usually use engineering notebooks for notes and things like that instead of separate sheet of paper. And then we document all of our findings and the failures and different things for that day. And thus begins the next leg of our journey.
After the plans have been made, they go about putting to work, venturing through the minds of Moria and Machina to create their great beast.
I think this is my I'm going to be talking about the building process and what we do. We started the year without an engineering mentor, really. We just had a programming mentor. But as the year progressed, an engineer became interested in it. His name was Vern, and now he helps out a lot. And he also helps us fabricate some parts, which is why we have things other than Tetrix on here. Our build process begins when we meet in the morning and determine the problem. So say we need to pick up blocks. We then will discuss and come up with several ideas for picking up blocks, like suction cups, a bucket, some sort of anti-gravity device maybe, and then we will put them on the board and vote for which one we feel will be most effective. And we'll typically end up with about 2, maybe, that we feel would work best. So then we go out and we build a prototype version of both designs, and based on that, determine any unplanned features or flaws of the designs. And then we'll hold another vote, determine which one wins, and actually put it on the robot. A lot of teams have a design that they want to get to from the very beginning. We don't. We generally just put it on one piece at a time, because we are a rookie team, technically, and that's how we built Excalibur.
So I'm kind of curious, you had mentioned the voting process. Have you run into any situations where maybe, part of the team has, wanted to go one way and part of the other team has wanted to go in another direction? And how do you deal with those type of issues? I'm sorry?
That was the prototyping thing. When we feel there's 2 designs that would work, we'll build a prototype of each and vote them.
Okay.
They had developed their great beast Excalibur, but there was a problem. For Excalibur had no life in it. There was no breath in its lung, no spark. And so they studied magic, the magic of Robot C, and they gave life to the beast.
Before we start to write the code, we have to do some research because as Char said, we are a rookie team. Most of the programmers, all the programmers except Ryan, have never really done any Robot C coding. So we have to do a lot of research, mostly on the Robot C forums and the FTC website. A lot of it was working with servos, which we didn't really know how to work, so we had to do some research with that. And then we do the initial writing of the code. Most of that, the autonomous programs, we split up. Each person does an autonomous program. But the function library, which we use, we all worked on that together, as well as the driving program, the manual driving program. And then after that, we have to debug. So we we put the code onto the robot and we drive it, and there's almost always something that goes wrong. We've misregistered, or sometimes there are real life forces that we just haven't accounted for, like friction, that we really just can't account for in the theoretical code. So we have to debug for that, and it's never done. There's always something that can be fixed. So the programmer's always pretty busy because there's just always something that's gone wrong, or something that has to be fixed, or something that could be better. So just always have to fix it, and thus begin the next version.
Go ahead.
All right.
I was going to ask you, what do you foresee as being kind of your greatest strength on your robot, and what do you perceive as being your greatest weakness or your greatest challenge for today?
Our greatest strength is probably we score blocks very well. Our greatest challenge is probably that we only have one person who can really drive the who can really drive the blocks, the scoop well, the bucket well.
We do have a few people. It's just
They're not all here.
Right, and they're not as
I would even go so far as to say the entire arm mechanism is our greatest strength, because it does pick up blocks very effectively, and it's also our hanging mechanism.
So, I see 2 sensors. How many sensors do you have on there? And maybe you can explain the sensors, what their purpose is?
There's 2 we have.
Go ahead and explain them. This is our IR sensor, which lets us know where the IR beacon is, so that we can put the block into the bucket. And we have another one over here, which is a touch sensor. This just makes sure that we don't have the bucket go too far down and hit the floor. Violently.
The first time we programmed that, we made sure that it didn't come up after we pressed that accidentally.
So the bucket will keep on going down until it hits the touch sensor and stops? Is that the
Yes.
idea?
Because we had some issues with the robot picking itself off the ground and grinding some
Oh, I
meters.
see.
Yeah.
It lifted itself, so it went down too far.
But as long as we're on the subject, also, those are only 2 sensors, but we also have encoders on 2 of the, well, on one of each side of the drive wheels motors, and that allows us to tell how far we've gone.
That's one of the other things that we had to research before we used.
Yeah, it's a bit more effective.
Okay, so you read that back in terms of distance or something like that?
Yes, we have a program in our function library that converts the clicks on the encoder to metric distance.
Okay.
If you would allow us, there is one more point to our story that we would
Yeah.
like to tell of.
Proceed.
So hearken. RPG, after developing their great beast Excalibur, knew that it needed to be shown off, and so they went about telling all lads of their great deeds.
So we went to the Cumberland Science Museum and we presented our robot to 200 kids. It was very fun. We've also, some of us in here have mentored 2 FLL teams. We've also demoed for 2 schools. We were in the Mount Juliet Christmas Parade and we had a gigantic robot walking around. So cool.
I think that was Josh.
No, it was Rex.
That was Rex?
Other one on the,
Yeah.
okay, yeah.
And
Yeah.
we also demoed at the Tullahoma FLL tournament, and we've also mentored a Tullahoma FTC team. We showed off our robot at the Wilson County Fair.
That's
what we
actually,
got.
yeah, we got Natalie there.
And we've also had articles published about us in various publications and magazines. So, and also I just want to say, at one time there was barely any teams in FTC. We were actually, our team
In
originates
FTC in
Yeah,
Tennessee.
Yeah,
We were the only
Tennessee.
one last year.
We were the only one last year. Well, it wasn't us, it was another team, and we branched off from them.
Okay.
So,
Almost the same.
yeah.
Now there are 14.
Us 3 came from that team. We shared one with that team. And we actually made it to World last year, but this year, this is technically a rookie team. And us 3 as the people from last year focus on not building, more just telling other people how to build.
We try to not touch the robot or the code, very much just instruct others so that they may learn for themselves, and so that when we do have to leave, they'll be able to take up the torch.
I'm curious, so you've got all your sponsors. How do you actually go about getting your sponsors?
One of our major sponsors was actually carried over from our last team.
Okay.
And I think it's our biggest sponsor, correct me if I'm wrong.
Yes.
Yeah.
It's Arnold Air Force Base.
Little fox.
Little fox. Some of them are from people we've done business with, like bought parts from. They've seen our team and have sponsored us, whether small or big checks. Some of them, like my dad, his company sponsors. If there's anything else.
So you guys have let me ask you this, so DCI Logistics, you get them to allow you to use their area?
One of our team members' fathers actually works there.
He's a pilot. He
Right.
flies.
So he just he let us work there. But that's we are a private team. We don't affiliate with a school or anything. So that's one of the reasons we have a lot of outreach so that we can try and get sponsors.
Usually we meet on Saturdays as opposed to during the week. We go down to the hangar 10
Yeah.
10 to
5
6 approximately.
So about 8 hours a week.
Being a private team also presents us with a few challenges to overcome, because mostly financially, because as a private team we do not have the funding of a school, so that makes these sponsors much more important, because without them this would be very much so impossible. and so we appreciate them very much.
Any other fundraisers that you guys do throughout the year? Or do you rely predominantly on the sponsorships?
Mostly sponsorships. There was a bank in our area. They had a job for us to do. Their mascot is a sort of robot man, and they wanted us to actually build him.
Well, that as I understand it, if you can stop me if I'm wrong, but that was something that we were going to do in the off season, and then they were going to give us a supplement for next year.
That was the only fundraising that we've actually done. Though most of it has just been sponsorship, but we intend to build a bank of robot, so they might enforce loans more heavily.
So, your little thing in the back,
Yes.
maybe you can talk about that a bit.
Yeah, that actually.
It is it comes out, we worked on this for a very long time.
Talk about the stage.
Go ahead and turn it on.
Yeah.
And we can push it out.
You actually have to turn the gears.
Yeah, you move your hand into it.
It began as just mounted on the back of our robots, but in order to keep it within the 18 by 18, we had to have it sort of inside, and it wouldn't actually be able to reach the flag. It would get caught on the corners, and we wouldn't be able to turn the flag. And so we had to redesign it and make it mobile so that we could.
It just, we fabricated a slide with some plexiglass, and it runs on a rack and pinion with a continuous rotation servo. And there's just a button on one of the controllers that pushes out and
And maybe you can explain how you, obviously I see the scoop, but how do you get the blocks into the grid?
What we do is we bring this down, and then we just go
We drive
and we push it. We just sort of we just slam
Like
it.
a shovel?
A bulldozer type thing.
Yes.
It relies heavily on there being a wall there, though,
Very much so.
because we can't actually get under them unless we hit a wall.
There hasn't been like an issue.
Yeah, because all of them have walls.
To make that.
The actual mechanism, though, is a 4-bar lift system.
Four-bar linkage, yeah.
4-bar linkage, sorry. So instead of actually having like a motor at the base of it, like a lot of teams do, we have a little servo up here, and when we move the servo, it allows us to tilt the bucket.
And it will remain like that through the entire moving up and moving down.
And what is that for? What is you?
It's to better get underneath the blocks.
So that if we have it flat, we can pick up the blocks, and then if we pull it up, they don't fall out.
I see.
And then we can dump them by pulling back in.
Okay, so it's not just a push, it's a pick up and then a dump.
Yes.
Also on the point of control, we have done a lot of work into talking to every person that was interested in driving, seeing what they wanted, and then we did our best to incorporate everyone's ideas into every control method. And we actually have a few different control methods to run the robot, different ways, according to people's preferences.
We also have a nice little cheat sheet with all the buttons labeled and laminated.
We want to make sure we have that.
Oh, I'm sure.
Our mentor got a laminating machine for Christmas.
So,
and he was so happy.
one last question I have is, are you guys dependent upon your partner in any way, or how do you work together as a partner team?
Well, we score blocks in one area, and then the other team will score blocks in the other area and balance out the pendulum. And then we're flexible with the team. If they can do flag and they can't hang, we can hang. And if they can hang and do the flag or hang, and
We just discussed which would be better.
And we can
Yeah.
also.
Really, the only thing that is big that we have to depend on them for is we can only do the IR block and autonomous in one side.
We have 2 other points, actually.
Well, our autonomous program, we realized that scoring the IR block was something that everyone did want to do, but there was a problem that arose because certain methods of scoring the block would cause you to run into your partner. So what we did was we created several programs that would each take the robot along different paths, so that no matter what our partner did, we could score the block and then get out of their way to allow them to do as they wanted, as they had planned, because we know that we are a team here. And we were willing to put in that extra work to allow the rest of our team, our overall FTC, everybody team, to do as they had planned.
And, sorry, one other thing I would just like to mention. There is a possibility of double hanging with our robot when it comes up. How our robot works, that arm comes up, it goes up very high, and hooks onto the bar, and then we back up. And while we're back here, it is very possible for another robot to just, on our team, to come up, also get on the bar and hang with us at the same time. It's not, our robot isn't specifically designed to pick up another robot, but we did allow room for another robot to help us out in that way. But I would say the main thing that we rely on another robot for is, while we can do both the hanging and the flag spinning, lining up takes enough time so that we can technically do both, but it's very hard. So typically one of us will hang and one of us will lead the flag.
We have more time?
I think, yeah, because we've still got one more team, so I think we're actually not